A very good day. We are from Team Bravo. We'd like to present to you our data science project, which is about uncovering Melaka's traffic congestion problem. For your information, KL is now ranked number 2 in the Asia most congested city rankings, where it has the index score of 1.4. What does 1.4 stand for? It means that KL people need to travel 34% longer time during the peak hours. What are the main causes for this? It's happening because of the high reliance on the private vehicles and also limited public transport provided to the people, and also the rapid urbanization. And this affect the national productivity, and also it increase the pollution rate and also lower the quality of life. Let's dive deep into the root causes for this problem. So the first reason is there are around 140% total vehicle increase since the year of 2000. So there are over 26.7 million new cars, MPVs, truck added to the Malaysian road since the year of 2000. And for your perspective, Malaysia total population in 2024 is only 35.56 billion. And moving on, the second reason is the urbanization rate. It's not just about the car that is getting more and more on the road, but it's also about the more people moving into the cities, where right now 75.5% of the Malaysian live in the urban area, which is far exceeding the global average of 55% and putting several strain on the city roads. The last cause is the low public transport usage in Malaysia, where only 25% of the Malaysians are using public transport, which is significantly lower when we compare to our neighboring country, Singapore, with the rate of 67%. This low usage of public transport usually correlate with the concerns about the reliability and also the coverage of the public transport facility itself that is often limited to the big cities. There are three main data sources that we use for this project. The first one is the primary one, where we get the official traffic data from MBMB, which is Majlis Bandaraya Melaka Bersejarah. They collected it through a camera installed at the Persimpangan Padang Nyiru for Jalan Temenggung and Jalan Bendahara. At the top here, you can see there's a cross sign where indicate where they installed the camera, which is between the persimpangan of Jalan Temenggung and Jalan Bendahara. They uses computer vision to detect and count all the vehicles. At the end, we managed to get the hourly counts of motorcycles, cars, trucks, and buses for all of 2024. The second data is the hourly weather data that we get from Meteor API. We get the data through making API call at the Meteor API, passing the exact coordinate of the monitored road. And after that, we match the historical weather data with the traffic data that we get just now. And lastly, we get the temperature, relative humidity, wind speed, weather code from the weather data. So from doing this, is able to help us answer the question where does rain really make the congestion rate worse? So whether the weather affect the traffic. And finally, we also added the seasonal holiday data that we get from public holiday API, where we make API call to get all the official 2024 holidays, specifically the national holidays and also the Melaka's holidays. And then we created the binary features called is holiday. It has a value of yes or no, indicating whether the day is a holiday or not. And we also map every of the holiday with the traffic data as well, so that we can see how the seasonal holiday will affect the traffic data, and also see whether the workday will got any different with the holiday. So by merging these three sources, we created a single powerful data set to help us find our insight.
Now, let's look directly at the cause of the traffic congestion. Our analysis from the previous data is clear. The congestion problem is fundamentally a private vehicle problem. This pie chart shows the breakdown of all vehicles counted on the monitor roads. The overwhelming truth is that over 85% of the road volume is composed of private cars and motorcycles. Specifically, cars account for 77.6% and motorcycles for 20.86% of the traffic flows. The trucks and the buses make out less than 2% combined together. This overwhelming reliance on personal transport is a core reason why traffic congestion happens. To solve the traffic problem, we must focus on solutions that reduce single occupancy vehicles. To tackle this, we must know when and why the traffic hits its peaks. This page shows us our findings on the typical daily and weekly patterns. On a daily basis, we see three key congestion spikes. The morning rush from 7 a.m. to 9 a.m., where everyone heads to work and schools. A midday slowdown for errands and lunch trips, but the absolute peak is the evening rush from 5 p.m. and to 7 p.m. as everyone leaves work at the same time. Looking at the week, the data identifies Friday as the worst day. Why? Because it combines the regular work commute with the start of weekend gateway traffic. People are rushing to appointments, leaving early, or starting their holiday travel. So, if you are traveling, avoid Friday afternoon. Beyond the community, we investigated how special conditions affect traffic. First, the holiday effect. The data on this page prove traffic is always worse on holiday. The congestion percentage is on average 2.5% higher on holidays than on normal days. This is because the surge in leisure and tourism travel more than offset any reduction in regular daily commute. Next, weather mean burster. Most assume that the worst traffic is on sunny days or during the heavy rain. Our data proves the real peak is during the light rain and drizzle. Congestion is highest, averaging over 25%. During these light and rain events, it's just bad enough to make drivers cautious and slow down, but not bad enough to make anyone stay home.
So after we have done the diving into the data sets itself and also doing EDAs, gaining visual insights on the data, we come up with the predictive solution where our analysis reveal clear patterns in Melaka traffic that is influenced by time of the day, weather of the hour, and also the holidays. But understanding the past isn't enough. We need to predict the future. So the first proposal that we want to give is to develop a predictive AI model. Maybe you can use different deep learning method or machine learning method such as LSTM using the historical data and also the actual real-time data. For this, we have to access to the online API such as TomTom API to get the most recent traffic data so that we can train a more accurate model. And this model should be able to forecast the congestion percentage up to 24 hours in advance accurately. And this model will be retrained again and again through our machine learning pipelines so that we can make sure the model is providing the most reliable response. What are the benefits from this? User can move beyond reacting to traffic jam to proactively anticipating them before the journey ahead. So they're able to plan their journey ahead so that they can prevent getting stuck in a traffic congestion. Lastly, we will deploy this as a public web app where we integrate the AI model with the web application. We will like to make it freely available to all the root users in Malacca, potentially across Malaysia. What are the features of this? It should allow the user to visualize the predicted congestion and also suggest the best travel time, and is integrated with a Google Map API which allowed the user to select and choose the specific road or area that they would like to visit. At the right hand side, you can see the wireframes containing the high fidelity prototype of the web app at the desktop view and also at the mobile view.
So, what is the conclusion? And what do we do next? The data clearly demonstrate that Malacca's congestion is a problem driven by private vehicles, reliance, and amplified by predictable peaks on Fridays, during the evening rush, and even during light rain. Understanding the past is not enough. We need to predict the future. Our core recommendation is to develop a predictive AI models that can forecast congestion percentage up to 24 hours in advance. We propose to then deploy this as a public web application, the Melaka Traffic Predictor, making it freely available to all users. This moves the public beyond reacting to traffic jams and allows them to proactively anticipate and avoid them before starting their journey. This is how we turn insight into real world impact. Thank you.